Welcome to this episode of the Structural Engineering Podcast, a podcast focused on helping structural engineering professionals stay up to date on technical trends in the field and to help them succeed in their career and lives.
In this episode, we're talking to Mark Kaiser, SE, a senior associate at RLG Consulting Engineers, about tilt-up construction and shelter designs.
I'm your co-host, Matt Picardle.
And I'm your co-host, Kara Green.
Now let's jump into our conversation of the week with Mark Kaiser.
Mark, welcome to the show. Now, we've briefly introduced you, but in your own words, can you please tell our listeners what you do daily at RLG Consulting Engineers?
Sure. So I am a senior associate here, and I lead a team of engineers, about 5 to 7 of them, on just various projects, because we work on, as a consulting engineer, we pretty much work on multiple projects at a time. But I lead a design team and kind of work through problems or challenges that our clients throw at us to help their visions come true. So I mostly focus into the client management, client coordination, and then quality control, and then leading and mentoring, teaching younger engineers or any and project managers working below me on how to basically execute a design strategy of how we're going to make our client's vision come true. So a lot of days I spent not too much calcing things out anymore, but definitely working through problems with them. I still do a lot of detail work, and then trying to communicate our design, not only to our engineers so they know how to execute the design, but even to the contractors whenever we put together our design documents. And then to another extent, I also work as, like I said, quality control. So since I am a senior engineer here, I'd make sure that, not only are we meeting, code prescribed life safety concerns, but even just functionality, serviceability things of the building that maybe the client has communicated to us of how they want their building or structure.
Mark, thanks for that intro. Could you talk about tilt-up construction? Can you tell our listeners that aren't too familiar with it, what it is and what your involvement with it is?
So yes, it is where the exterior wall of the building will be cast on site, face side down on a casting bed or your slab on grade. They will lay out the reinforcing, any sort of embed plates, lifting inserts, pour the concrete. Once the concrete has reached sufficient strength, which is usually about 75%, a crane will come lift the panels and physically tilt them up off the ground and into their final place. Where then after your exterior wall is pretty much put in place and then temporarily braced for the construction loads, they will then erect the interior steel frame of the building and then eventually tie them in with either your floors or the roof diaphragm.
Gotcha. And that's basically different from typical concrete construction where they have to, basically, if you were doing a typical wall, they'd have to get all the shoring up or the formwork up for the wall, and then they'd have to put in all the rebar versus this tilt up where they kind of just pour it like a slab on grade and just tilt it up, connect it into place, and put on the roof and call it a day.
Yeah, the benefits of it is you basically don't have any exterior. I mean, your exterior wall construction is the wall panel, right? And so the only forms are basically like your ground forms. So it's usually, depending on the size of your tilt wall, they usually follow a good rule of thumb is going to be a standard lumber size. So if you're doing usually some smaller single story applications, it's a 5.5 inch thick panel, because that's a 2x6. If you're going multi-stories, it's a 9.25 inch panel, which is a 2x10 that basically they nail down onto the ground to create your forms for it. And so when you have the tilt wall, it basically speeds up construction because you've now cast your exterior wall. So that's your basically your finished exterior wall, your lateral system, your gravity system for the perimeter. Once that's up and in place, then you just do the interior steel frame and you're pretty much good to go. Now they will always do, especially for insulation purposes and getting your R values and everything, there is usually a furring wall to the inside because they will have to add if you're not doing what's called sandwich panels and adding an insulation layer to the outside, you still build an interior metal stud wall to get your insulation values for the architect and stuff that are there. But it still speeds up construction. When you see a tilt wall building go up, it goes up quick compared to your conventional concrete construction.
Yes, and I think one of the most impressive things, and you mentioned it, is actually lifting it with the cranes. I've been on site when they've done it with the cranes, and it's like, it's really impressive how easy they make it look, even though it's actually a fairly difficult process.
Yeah.
And like you mentioned that you were in Texas, and so am I. When you get like the wind gusts,
Yep.
it that big panel like sails,
Yeah.
like a ship on a sail ship.
Yeah.
Or
So
a sail on the ship.
Yeah, there's multiple things that go along with it. So obviously we engineer the final in-place design, but there's another step that people don't think about, and it's usually handled by the contractor and the basically the concrete sub. We engineer it for the final in-place condition, but for construction purposes, they will have a lifting and rigging engineer basically look at what's there and look at the lifting loads and the temporary wind force on there, because that's how they determine how they're going to lift it, because sometimes they need to either add Strombacks or additional reinforcing to what we require in order to lift the panel into place. So frequently you'll see some added bars and we review it, we get the submittal for it because we get to see what their lifting requirements are and how they're going to brace it off for the temporary construction loads. But that's always an interesting piece that people don't really think about when it comes to the tilt wall design, as to how you get it from, the design drawings into the in-place physical form.
Yeah, it's very interesting. I know some people take on the crane design themselves if they have that internally. And then sometimes the contractor subs that out to someone different. But to follow up, so you mentioned that you have the tilt up construction, which is a slab on grade construction where you essentially lift it up. Can you kind of further discuss like the difference between tilt up construction, as you just spoke about, and precast?
Sure.
Because we're seeing a lot of precast construction come about as well.
Yeah. So precast is basically, in the final design, or in the final in-place thing, they're kind of the same, but precast is basically panels that are done at a particular plant, and then they are shipped to the site. So they have they are usually a little bit smaller because you're kind of limited to what you can truck in, right, in terms of width and width and weights of how you're going to get it from the precast plant to your job site. Tilt up is, like I said, is actually done on the site. So if you have enough room to do these casting beds, because that's one thing you always have to do, you always have to consider with your site plan is there enough level ground and is there enough room to actually cast these things on site and then lift them up. So it is an exercise a little bit with either an experienced engineer, or if you have a contractor on board, even better, that can help you lay out like, hey, can we even physically do tilt wall on this site? Because a lot of times, let's say you're working on a downtown urban site, it's not going to make sense. You can't do it because there's just not enough space to do all that, to do the casting beds for it. Now, if you're in like a green field and some of these bigger developments, and one of them here in the Dallas area is Cypress Waters, that is a big office complex where they've got plenty of site where most of those offices there are tilt wall construction. And so they have the room to do all the layout, the casting beds in order to do this panels on site.
I have a follow-up question about this, because this is something that I was always really curious about. I know a lot of times it has to deal with like how much land you have to do the cast in or tilt up. Is precast preferred? Or is there any sort of like, because the way I always thought about it is when you think of precast, I think of them as being obviously transported in, which means they're likely to have potential for damage, cracks. You have to do like the little patch repairs, grout repairs, that sort of thing. So I was curious if as a design engineer, if you've seen benefits for either.
I see benefits in terms of what the architect wants to do for their building. What I will say is with tilt walls, a lot of the architects here have been getting very creative, and I don't want to say pushing the limits, but let's say pushing the boundaries of tilt wall and getting a lot more creative with the panels that they use and how they, how their vision of the building is. Where in precast, you can do it, but I mean, it's not as, creative as a process. I'll say, not to say they can't do it, but I'll say with the tilt wall, you're allowed a bit more freedom to it. But what I'll say is just even think of maintenance of a building. There's a lot of pieces and joints that go together with a precast building, which lends itself to basically the owner accepting long-term maintenance things, because the building, when it comes to precast and how all these joints come together, are only as good as that they're sealed, protected, and maintained. Where as opposed to a tilt wall building, you are going to have to patch some areas, because things do happen, and like with cast in place concrete, sometimes you do have some defective areas that needs patching, but at the same time, it's a monolithic panel that you're putting there, and you're really only worrying about like one, the panel joints, and that's usually that one vertical joint in the wall system that you're really maintaining. After that, it's pretty much an enclosed building, so you're not dealing with all the sorts of maintenance issues that you're going to have with precast versus tilt wall.
What about the pre-engineered steel buildings? How does tilt up compare to that? Is it cheaper or?
No, what I will say for sure, it's not. You're kind of looking at two way different buildings there. Usually, if you're looking at a pre-engineered metal building, you're limited to usually one story, so it's going to be one big frame. Not to say that there's not like a mezzanine or a second floor that they do, but they're usually 1 to 2 floors at best. Where tilt wall, and if you've even gone down to Houston, people are going, we've done 5-story tilt wall buildings, and some people have stacked tilt walls and gone up to 6 stories on them. We do 3 and 4 story all day. Like I said, 5-story is, there's a couple of them out at, this Cypress Waters development. And I know in Houston, they've done 6. I think there's actually one on the sorry, I'm getting a little too local, but there's one here off of Dallas North Tollway that is a 6-story tilt wall building. So no, I mean, you're not, in terms of your costs, a pre-engineered metal building will always be cheaper than a tilt wall, but you're kind of limited to what kind of building you're doing. And like I said, it's usually single story in the overall structure, but maybe you're building a mezzanine to get a second floor inside that. So think of a box within a box. But
interesting. I always just think of, I have a really good friend that I went to college with, and that's what he does now. He does pre-engineered steel buildings for it's the Dollar Generals.
okay.
I think they're here in Texas. There's a lot of them in Alabama, but yeah, that's what I always think of, as just literally a small little metal box.
Yeah. I mean, you can get some pretty good ones. I believe, like, I happen to play hockey in Plano, and so one of the ones that, like, the Dr. Pepper Star Center there is a pre-engineered metal building. So you have 2 sheets of ice and a mezzanine that are in there, so they can get pretty good. But it's so I don't want to limit them to just Dollar Generals, but yeah.
No, that's just what I remember him telling me. Is he's like, I build maybe like $20 Generals. It's like, all right. And he obviously does much more as a structural engineer, but that's just what sticks in my brain. Yeah. It's like, oh, he does all the Dollar Generals. All right.
Odds are that's it. Yeah.
So I did want to ask, and this was mentioned to us. So you have also, and of course we're in Dallas, and I'm from Alabama, which is a little bit of part of Tornado Alley. It's been mentioned that you are heavily involved in tornado storm shelter design. Can you kind of elaborate on your involvement specifically with shelter design?
Sure.
We've been talking about, preformed or pre-engineered steel buildings, and those just go up. We've all seen the tornado movie.
Yes. We for now, because of the 2015 IBC, it has now become a code requirement that basically your essential facilities, so 911 call centers, police, fire station, ambulance facilities, so anything that's supposed to be in service after a disaster, and your basically any group E occupancy. There are some minor exceptions, but think if you're doing a new school or a significant school addition, the 2015 IBC now requires that storm shelters be a part of that new construction, provided that you're within a designated wind zone of 250 miles an hour for a tornado. And so the 2015 IBC requires that. Now, if you're looking at the ICC 500 2014 is the current design standard for tornado and hurricane storm shelters. They basically give you a wind map of where that 250 mile an hour zone is at. So it touches North Texas and obviously your traditional tornado alley, but it even goes up to I think parts of Indiana and Illinois. So it goes a little bit farther than what you would probably recommend, but it goes a little bit farther than what you'd probably think of when you think traditional tornado alley. So when we have those projects that come up, which I do handle a lot of education projects in our company, we are the structural design engineer for tornado shelters, and there's multiple ways you can do it. You bring up tilt wall, as long as it's detailed properly, you can do it. A tilt wall project that can serve as a storm shelter. Precast is another one too. There's a lot of people that for space reasons will use gyms, and they'll go with the full precast concrete approach. I've also done projects that are insulated concrete forms with steel roofs, masonry, and just your traditional cast in place concrete structures. So we will design per the standards a tornado storm shelter to basically handle up to 250 mile an hour wind speeds.
So we've officially moved out of, you have to go, I don't know if y'all were ever taught this, but in Alabama, we were taught like if you're caught outside, you have to go into like a storm drain pipe or like go underground. Yeah. I mean, that was what we did when I was growing up. So we have officially moved out of the going underground or going into a storm pipe.
Yep. So yeah, we've done that. It's now basically we're building buildings that, provide life safety. Now, they're designed basically to not collapse. They may not look pretty afterwards. You may have to knock it down, but it's basically there to save the lives of the occupants, in that structure. You can get, I don't know if you've been to Lowe's or even Home Depot, but you can buy, they make them that you bolt to your house, your house slab on grade too. But that's a whole nother aside. That's a whole nother aside. But yeah, no, we will frequently either turn like a portion of a classroom wing, a single story classroom wing, or even 2 stories we've done into a storm shelter. So what we'll do is we'll basically use, depending on what the client wants to use, or if there's a contractor on board, what they recommend in terms for cost reasons, because you are paying, you're paying a little bit of a premium to beef up that portion of the structure in order to get there. So I do want to say it does increase the cost of the project, but you have to think of it's only a small area of the entire project at which you're doing. So we've looked at masonry, and those are, those have height limitations that we certainly try to keep within before switching to like concrete or an insulated concrete form. Tilt wall can also work as well if you have the space requirements for it. And then traditionally, we'll have a composite steel roof on top to not only help us for weight for wind uplift, but even the loads that you have to design for vertical loads for either wind or collapse loading. We usually need a pretty strong roof structure up there to withstand those.
Yeah, I'm curious. Is it when you're designing tornado shelters, is it basically in terms of design, you just bump up the wind speed to what they have, or are there any special provisions? Because I'm in California and I'm like comparing it to like earthquakes and
sure
have to do special stuff. Is like tornado anything special, or is it just really high wind speeds?
Well, no. So there is things that you have to consider. So like I mentioned, ICC 500 is the current design standard. And what they do is they provide modifications to your live load. They specify a minimum roof live load of 100 PSF for your roof that needs to be designed for. But then there's modifications to the ASC 710 wind forces that you calculate. So you're obviously going up to the 250 miles an hour that you need in this area. I should say you can do a tornado shelter, other ways, and they do give you, if it's outside the 250, you design for if it's 200 or 150, and that those maps are in there to tell you. So you can certainly design storm shelters that are not 250 miles an hour. But then you're forced to design it for exposure C. And then you also, unless you're working with a mechanical engineer to deal with there's a pressure differential that you have to consider. You're designing it as basically the out is always designed as a partially enclosed building. So your internal pressure coefficient is 0.55 as opposed to the 0.18 that you're traditionally using for your normal commercial building. And then they, for your directionality factor, usually we see 0.85 for a typical building when you're using when you're doing a commercial building, but then they modify it to say you have to use a 1.0 factor for that. So you're basically, in addition to bumping up the wind speed to 250, you're taking some other increases that are on there based on the provisions of ICC 500. It also goes into the effects of where you locate your storm shelter on your site plan. So if you're adjacent to another structure that's not designed as a storm shelter, you need to basically consider rollover or collapse loading onto your storm shelter, because like I said, it's, the intent of it is to serve as a life safety. So you need to be able to handle structure collapsing around it or on top of it to protect the occupants. So while you do have a minimum live load of 100, you could easily get to the 300 to 400 PSF, because you have to consider something. If your space site plan requires it, something collapsing on top of it. And that usually does have to have an impact factor for something falling on top of it.
Wow.
Yeah.
That is so interesting. It's funny. So I was watching, I don't know why I like these YouTube videos, but they're like the failed demos.
Okay.
But there was one, and I think it was a Ukrainian building, or a building in the Ukraine, and they did a demolition plan, and it killed like a portion of the foundation, and the actual building just rolled over onto its side, and there was like an existing apartment building adjacent to it, and it like stopped just beforehand. And that's all what I'm picturing. I'm just picturing this like big apartment complex just like rolling right over onto a storm shelter. So it's good to know that you're protected if that does happen.
Yep, we are forced to design. ICC does cover that condition.
Like I said, I don't know why I watched those videos. That was during quarantine. I really got into those failed demolition videos, but it was really interesting. But that's good to know that that's something that's planned for.
Yep,
for sure.
What about the future of shelter design? Is there anything that, because I'm not too familiar with that. I mean, I'm familiar with earthquakes and foreign space design, but what about the future for shelter design? Is there anything interesting that's coming up?
Well, I think I know they're just now doing a big update to the design standards. So there is going to be some more prescriptive things that are coming on with the new ICC 500 that's about to come out. They tried to clarify a lot of things and give engineers a lot more direction and a lot more uniformity to what people are doing. Because one thing you got to consider is, even like I stated, for like collapse loading and an impact factor. Well, who determines that? What is it? And it's basically the engineer's judgment as to what they think it should be. But some engineers could use an impact factor of 3, because that's what they're comfortable with, or one could use 1.5. That so now there's things like that are coming up. In terms of kind of interesting facts or interesting things that come up with it, I would say a lot of it has to come with the products that are being used for the products that can be used to, I would say, maybe enhance or give a little bit more freedom to the designers, and mostly for, I would say, the architects, to doing these storm shelters. Because one thing, when people start thinking storm shelters, you think, oh, it's just going to be this ugly box, right? How do we get, we want windows and stuff on there. So there's been a lot of there has been, there's, impact resistant, windows now that you can use in there. So you can actually have windows. Now they are a premium cost, because they have to handle a 2x4 missile going 100 miles an hour hitting it. And so, there's certain types of there's windows or storm shutters that are being tested or coming, products that are coming to market that allows just a little more flexibility into the designs. We also frequently have to deal with how are we going to service the building. So mechanical penetrations through that envelope, whether it's through the roof or the wall structure. and the code makes you basically have to provide some sort of protection if any opening is greater than 3.5 square inches in area or 2 1/16 inch diameter. If you have an opening or penetration through your exterior envelope greater than those requirements, then you have to provide protection via baffling or something. Well, there's products on the market out there that allow that penetration to happen without providing some sort of clunky structure or miscellaneous significant miscellaneous steel to help provide that protection, whether via louvers or some sort of housing penetration housing that allows them to, I guess, more cleanly allow that to happen through the exterior envelope. So that's kind of what we've been seeing. It does take a bit of research to find something that's not only tested but approved, because that's still the one great thing is you have to have all these things tested for missile impact in addition to the wind design pressures that are needed.
Wow.
Yeah.
Missile impact. Oh my
Sounds
gosh.
intense.
So you've mentioned, so there have been the updates, which it sounds as though have presented some interesting challenges, especially with accommodating those sorts of code changes. And I was curious, obviously structural engineering has a bunch of challenges, especially, and it varies from project to project. Can you kind of describe or talk about one of the most challenging projects that you've ever worked on that really benefited your career as an engineer, even just like, not even your career, but maybe your just knowledge base that expanded your thoughts about how to approach certain problems? Can you talk about that a bit more?
Sure. I would say, and believe it or not, I would say it's probably one of the most recent ones that's wrapping up now. So we were fortunate enough to work on, it's called Weir's Plaza. It's down here in downtown Dallas. It's going to be an iconic building in this new redevelopment of the Knox Henderson district, where was a 12-story Class A office building with 6 levels of below grade parking in an urban environment. The challenges it had was we were digging basically, like I said, 6 levels of below grade parking. So we had existing buildings and existing basement foundations that we were going to dig next to, and the added complexity of historic facade preservation. So the Highland Park Pharmacy is on this site, which dates back to the 1900s, which was a soda shop, a pharmacy, and then a soda shop that people in that area loved and wanted to maintain that historic facade. So we had the challenge of doing this new office building, but we had to save a multi-white unreinforced masonry facade from, I think it's 1906, but anyways, the early 1900s, from the 1900s, that we had to keep in place during construction of this new building. And so, there was certain challenges that we had to, one, come up with a bracing scheme that did not was not too intrusive on the existing facade, but allowed us to keep it in place while excavating rock right next to it. So we had to keep the foundation system and the wall itself in place. We had neighbors 4 feet away from our basement wall that we were going to dig below. So we had to work closely with, that neighboring property, the geotechnical engineer, the shoring contractor, to make sure all that stuff was accounted for. There was monitoring systems in place, and the contractor did a fabulous job of, doing their due diligence of documenting existing conditions, installing coming up with a monitoring program, communicating with the neighbor. How are we going to backfill how are we going to build our wall, backfill it, and not cause any, damage or, any unexpected loads to that neighboring structure. And then, obviously giving our client and their client, the best possible product for their building. So that had multiple challenges, and I got to learn, a lot about whether it's geotechnical engineer, retention systems to, dig that far down, coming up with construction bracing loading, coming up with just even performance specking, construction monitoring. So we make sure we're not, causing too much, vibrations to a historic facade or an existing building. Yeah, there's a lot to that. It is probably to date one of the coolest projects I've ever worked on, and seeing it go up now, it's pretty much they're just doing the finishing works to it. So finishing up the brick veneer and doing the glass, watching that going up is just, amazing. It's like I said, it's going to be one of the most, probably one of the, looking back, I've been doing this for 15 years. I can say without a doubt, it's one of the coolest buildings I've ever done.
Yeah, it's definitely interesting. 6 stories below ground, existing facade, and all the neighbors too.
Yeah, it's like I do love sharing the photos, because we have photos of them basically being at, the basement slab on grade, getting ready to pour that, and I'm standing on the top of this hole, and then you're looking at just this wall that is braced to one side, just kind of dangling over the side of it. And I just remember, like, we, just sitting there just in awe of, like, look what we're doing. This is pretty cool. And now it's all tied back in. There's plenty of times where I just sat there. It's like, okay, what's the wind going to do? If a storm came through here, I'm like, oh man, I don't want to call. I don't want to call. Because that facade was very, like, it's very important to the residents of that neighborhood, which within good reason. It's been there for, over 100 years. So they want to keep it. And, we appreciate that. And we wanted to make sure we had that happen, not only for the developer, but for the residents of that neighborhood.
Mark, in the engineering industry, a lot of the engineers are obviously good at technical stuff, but when we talk to a lot of people, communication is one of the things that they can always improve, especially since you're an associate over there, where you're not just talking to clients, but you're also talking to different types of disciplines, contractors, architects, and even newer engineers. What can engineers do to be better communicators, and what benefits do you see from improved communications?
So the biggest thing that I tell and that I encourage the engineers working for me is to pick up the phone. Like, I think, pick up the phone and call, work with the architect, establish a relationship with them, even so much as to, even ask them how their day is going. There's, engineering, while it is, calculations, science-based, this is still a relationship business. And so I encourage them to pick up the phone. Like, that to me is, the best thing. We can always send an email, but the more that we're in front of our clients, or even our team members, or the mechanical engineer, the geotechnical engineer, talking through with them, over the phone, or even better is face to face, working through those problems. I find it so much more easier to do than and so much easier and beneficial for all parties to have that, either voice or face to face communication. Like I said, I think just with the technology, we start leaning on a lot of emails and back and forth on that. But to me, there's nothing better than just, talking it out, working it out, and even just getting to know the people. Because, one thing that I always also try and impress on them, this is, like I said, it's a relationship business. And one part of it that we don't learn in school is the business development. So as a consulting engineer, like, and the position I'm in, I'm not only responsible for the work that's done, I'm also responsible to bring in work. And how do I do that? I need to make relationships, and people want to do business with those they know and trust, and so how do I'm not going to get that by just firing off random emails. Hey, structural engineer here. It's, talking to clients, getting to know your clients. That I feel like that's something that's missed. And we don't learn it in school. We learn it basically as we grow up in the engineering field. And you see your bosses doing it. How do they bring in projects? How do they, how do you meet these people? How do you network and do this? That's something that's not taught. It's learned. And it's, as engineers, we're usually pretty introverted, right? You think of the typical engineer just, doing calculations behind a desk. Well, you know what? There's a whole, whether it's civil, structural, mechanical, there's a whole nother aspect of it. And it's, business development, it's relationships. So the more I can, impress upon other engineers to just work on communicating, like I said, face to face, over the phone, get to know the people you're working with, the more you build that trust and that relationship with, the better that you're going to be, not only in just your engineering, your engineering and your coordination skills, but even your future business development skills, and how you're going to, grow as a professional throughout your career.
Oh, that feedback is so nice. And I love hearing it because it mirrors my thoughts exactly as I've become a professional and moved forward and as an engineer as well. Because at the time I've talked to Matt about this before, like back when I was a design engineer, I like sat in my little box and like I did my calculations, and that I was like super comfortable being full on keyboard warrior. But you know, you don't see that growth in your career until you start networking, and until you start building those relationships, exactly as you said. And it's like invaluable how important it is.
Yeah. And we like, and so one of the first things that we do here at RLG when we have new engineers, we do try to get them involved, even if it's on a project they didn't design, but it's doing construction management. So letting them be the point of contact. So now we're kind of thrusting them into, you need to communicate with your counterpart that's, you know, the contractor out there. So give them a call, schedule this, make, you know, you're on there figuring out submittals, RFIs. So we try to push people a little bit out of their comfort zone a little bit, because and it's daunting, and you know, I will fully acknowledge that when you're fresh out of school, you're like, I'm gonna go tell this, you know, person, like, here's what I need, or here's how it's, you know how we're gonna answer this, or if, you know, knock on wood, hopefully this doesn't happen, but something goes wrong on a site, you know, in terms of like a construction error or something that wasn't built correctly, how are we going to handle that? You're going to work through that problem with that person. And so, like I said, trying to push people out of their comfort zone a little bit, and I think it, you know, it pays dividends in their future.
Most definitely. And so to end off here, and I appreciate this entire conversation. This was such an amazing, like I said, you hit so many key points, because I used to think about tornado construction, but of course that's back when we were staying in basements. But to end off here, so for structural engineers considering doing work in Tilt Up, or any part of the work that you have been doing, because it sounds as though your projects are so diverse, you know, what advice would you give them? Because we do try to give advice to younger engineers or professionals looking at doing something different. What is advice that you would give structural engineers?
So when it comes to, well, particularly for tilt-up construction, advice is to, one, pay attention to panel weights, because obviously cranes are lifting these things. And so, you know, good rule of thumb is keep your panel weights, you know, about 110, 115,000 pounds, or, you know, kips, because you know, your typical crane can really lift that. Once you get above, you know, certain panel weights, you have to get a special crane to lift those, obviously, because that's, you know, it's all weight based. And then when you're, especially with these, you know, commercial buildings that we're turning, you know, using tilt wall for office buildings, I mean, you really have to look at, it's not really, while it's still a wall panel, it's more of a, you know, we find them more to be a slender column, or, you know, it's a tilt beam and column approach, because these openings that are punched into these wall panels are so big that it's not really a wall so much anymore. When you look at the elevation of it, it's actually kind of like a slender column. But in terms of, for any structural engineer, any advice I'd give them, I would circle back to, you know, get out of your comfort zone, do things, you know, especially when it comes to communication, always be learning. There's so much more, you know, there's so much, you know, new design approaches that come on, like, especially with performance-based design. There's new products out there. Like I said, right now, you know, insulated concrete form is getting very popular around here, because you have the benefits of a cast in place concrete wall, but it's no formwork, or it's the formwork is kind of more like a masonry approach. So just be open to new ideas, new concepts, you know, new ways of doing things.
Thanks, Mark. Yeah, we really appreciate you coming on and giving us this conversation.
Thank you. It was a pleasure.
I hope you enjoyed the episode today. We would love to hear your feedback, comments, or any questions you may have. To leave them, please visit structuralengineeringchannel.com. There you will find a summary of the key points discussed in today's episode, which is episode number 55, as well as any links to any of the resources, websites, or books mentioned during this episode. Don't forget to subscribe on Apple Podcasts or wherever you listen to your podcasts. Until next time, we wish you the best in all of your structural engineering endeavors.